Hi, it's Robin. Just working outside here on the snowblower, changing the oil, clearing my driveway. Sure is hard work. Oh, my hands are filthy. And my manicurist is off on vacation. Oh, and my nettoyant à mains avec Pierre Poncelet essence d'agrues très poisson is frozen. Can't even clean my hands. Just have to do what I can. That'll do. This is the patron exclusive video for February 2020. Back in the first video, October 2019, I was planning on reviewing my 3 favorite Commodore 64 programming books, but I came to my senses and realized I could talk for like an hour about just one of these books easily. So anyway, I just covered the C64 Programmer's Reference Guide. I'd still say if you could only have one Commodore book, of course nowadays with the digital copies you can get for free, that's not relevant. But if you could only have one book, this is the one. It's really an amazing book considering it came out right at the beginning of the Commodore 64, and I think it played an important role in the C64's success. Anyway, so that's definitely check that one out if you haven't already. So today we're going to talk about my second favorite book. So this might be the second Commodore 64 book I ever bought. After the Programmer's Reference Guide I bought I think in 1984. I don't know if I got any other Commodore books. I didn't get this one until the mid to late 90s. I bought it from CMD. I saw it in their catalog and it looked interesting, so I ordered it. I don't know if there was... so I might have had a 12 plus year gap there where I only had the Programmer's Reference Guide and then I got this. This was an amazing book, and this really opened my eyes to certain aspects of the 64 that the Programmer's Reference Guide didn't cover. Now, this is actually the second edition. It says it's covering the 64C, including a complete memory map of GEOS, so both the Commodore 64 and 64C personal computers. More recently, I got the original edition here, and in case you're looking for this book, as far as I can tell, these are nearly identical, except this one has the edition of the GEOS guide. So I wouldn't be concerned if you find this for a good price and you can't find this one. I wouldn't worry about it. This one should be fine unless you really want that GEOS memory map. Well, that's up to you. And just to compare the two briefly, so the original is copyright 1984, and the new one is copyright 87 and 84. If we look at the contents, they actually are... I haven't like gone through word for word, of course, but if you compare, it goes all the way to chapter 7. They all have the same page numbers here in both editions, and then this one has chapter 8 added for the GEOS, and then the appendices are still A through H, and then there's that extra GEOS index. So I really think they're more or less the same. So today we'll be using the newer edition just in case it's a little different. Also because it's the one that has my notes and my scribbles and so on in it. So of course I'm not going to go through every page of this, but my point here is to introduce you to this book, show you why this particular book is valuable, and I believe it's on archive.org, or you can find a physical copy. I think it's really worth it for expanding your Commodore programming knowledge. So in the foreword it says this is actually the 4th printing, and now they talk a bit, this is a new foreword. In case you don't know about GEOS, it's just the graphics environment operating system. I won't really be talking about that today beyond just explaining that the 64C included GEOS when you bought it, or was it with the disk drive? Anyway, so Commodore was officially distributing GEOS when you bought a new Commodore system. But the 64C, they did not change the ROM. This was just GEOS came on a disk. So of course, programmers would be interested in this. Some programmers would be interested in this. But really the 64C, which is the white cased one that I use in some of my videos, or the breadbox 64, they're very similar. In fact, even looking at the 64C, you can't even tell if it has new or old SID and VIC chips in it based on looking at it, because Commodore infamously just used whatever they had around. So you can get a 64C from the factory that has all the old chips. It has like the 12-volt SID instead of the 9-volt SID and so on. And here in the acknowledgements, he's actually acknowledging of all the published sources of information about the 64, he's found the C64 Programmer's Reference Guide to be the most valuable for technical information, that Commodore has come out with such a thorough reference work so quickly after the introduction of the machine is much to their credit. Because of the similarities between the 64 and previous Commodore computers, I've also heavily relied on books that deal with the PET CBM. Of particular interest are Programming the PET CBM by Reto West and the PET CBM Personal Computer Guide. Those are both excellent books if you're interested in programming, and they are relevant to the 64 to some degree. My third favorite Commodore 64 book is Reto West's C64 version, Programming the Commodore 64. So we'll get to that maybe next month, I don't know. And to explain what this book is about, might as well go with the introduction here. To many computer users, the concept of a memory map may be an unfamiliar one. Simply stated, it is a guide to your computer's internal hardware and software. Now, here's the complete Commodore Inner Space Anthology by my friend Carl Hilden, the former editor of Transactor magazine. And you see here it has a whole section called Memory Maps. So let's take a look at one of those. And here's one's VIC-II and VIC-IV memory map supplied by Jim Butterfield. So basically it's both for VIC-II in the early PET and VIC-IV, which was in the later PETs. And all it is a listing of addresses and then a description of what is in that memory address. That's one of the nice things about these old 8-bit computers is how things were in fixed addresses. And that's a big part of when we disassemble an existing program, a game. We can look at some of these key memory addresses. Once you have them memorized or familiar with them, or even if you don't, you can just look them up. And you can get a sense of context when you look at code, even when you don't have the source code. By knowing what these different memory addresses do, or looking them up, you can imply some context into code. And that's what I do whenever I'm working on fixing a game or whatever, which I hope to get some of my videos done about those. So I don't know if it's Jim Butterfield that invented the idea of a memory map or coined the phrase memory map, but I do know he was instrumental in supplying these memory maps in the early days of the Commodore 8-bit computers. He may have had some inside help from friends at Commodore. I don't know, I think Jim Butterfield is heavily linked to the concept of memory map. I don't know who actually coined the term or whatever, but that's the way it is. And these are the Jim Butterfield ones where it just gave a brief explanation. And if you are familiar with the C64 Programmer's Reference Guide, and you see here on page 310, the Commodore 64 memory map, it also has the label names. I suppose these labels were used in the source code. So mapping the Commodore 64 is a memory map at extremely deep level. It's turning one of those memory maps, but instead of just giving a one-line description, they write sometimes multiple paragraphs or even pages about each memory location or each section. So this introduction is an excellent read. I'm not going to read it for you, but I recommend you get a copy of this book. And this is some excellent introduction. So it talks about how there are 65,536 bytes of memory in the Commodore 64. Each byte of memory can hold a value from 0 to 255, and the computer can read and sometimes write information from any of these locations by using its address. And it describes bits and bytes. I'm sure many of you are already familiar with this, but if you're not, here is an excellent introduction. It talks about the low byte and high byte order, or least significant byte and most significant byte. A section about hexadecimal, using the AND, OR, and exclusive OR functions to manipulate individual bits in a memory location, and also how the book is organized. Rather than just listing every memory location, there's a couple levels kind of separating the Commodore 64's memory map into blocks, such as 0-page, basic ROM, and so on, and then kind of narrowing the scope until you get to individual memory locations. And here, sometimes the single line descriptions will identify a location as a flag, a vector, or a pointer. A flag is just a number that the program uses to store the outcome of a previous operation. So it could just be a single bit, like true or false, but a flag is an 8-bit value. Sometimes it's just a single bit that's used. But here's the difference between a pointer or a vector. It's usually a 2-byte location that holds a significant address. Pointer is usually used to point to where some data is in memory, while a vector points to code, to a machine language program. But sometimes these terms will be used interchangeably. Okay, so we'll just take an overview of these chapters. So chapter 1, page 0. And actually I'm going to be talking about this more in the Ask Robin this month. That's a little spoiler. Memory locations 0 through 255. That is the first quarter kilobyte, if that helps, of the 64 kilobytes, have a special significance in 6502 machine language programming. The 6510 in the C64 shares the same instruction set as the 6502. Since these addresses can be expressed using just 1 byte, instructions which access data stored in these locations are shorter and execute more quickly than do instructions which operate on addresses in higher memory, which require 2 bytes. Because of this relatively fast execution time, most 6502 software makes heavy use of 0-page locations. The 64 is no exception and uses this area for many important system variables and pointers. And then in addition, locations 0 and 1 have special input-output functions on the 6510. Yeah, locations 0 and 1 are important. The programmer's reference guide doesn't do a great job of explaining locations 0 and 1, which are a special data direction register on the 6510. That is, on the 6502, all of 0-page is expected to be RAM, well, assuming it actually has all 256 bytes hooked up to RAM. But on the 6510, locations 0 and 1 are actually I/O ports in the processor itself. They're not RAM. They control a 6-bit input-output. So location 0 is the direction that each of those ports, is it an output or is it an input? And then location 1 is the actual data where you control whether that bit is on or off, or you can read out of it if it's an input. So bits 0, 1, and 2 are the low RAM, which it controls whether ROM or RAM is seen at location 1000. So either basic ROM can be there or RAM. High RAM is whether the kernel or RAM is in there. And actually some of basic overflows into the kernel ROM. It's not as clean an 8K separation as some documentation makes it sound like. And then finally, whether the character ROM is available at D1000. And then bits 3 through 5, the other 3, are the cassette input and output. So it spells out that there's actually 88K worth of RAM, ROM, and input-output space that the C64 has. And so these signals here are used to switch some of those ROM and RAM spaces in or out. Now, the Commodore 64, this description isn't completely accurate. The programmer's reference guide, as far as I can tell, just spells out like this, and it's not the whole story. Mapping the C64 actually explains this better. For example, you would think you should be able to switch the basic ROM in or out and the kernel ROM in or out independently, but according to this, if you switch the kernel ROM out and put the RAM in instead, then the basic interpreter is also automatically switched out. That seems kind of like a strange decision. It makes sense logically that they would do that, but it seems strange that they would have this bit override this bit, but apparently that's how it works. And then this book helped me understand for the first time that there are also these other signals besides bits 0 through 2, where you switch those ROMs in or out. there are two lines on the expansion port, the cartridge port, called Game and XROM. Those also play into this configuration system. I should probably make a video about these. I think Greg Nassau wrote up an excellent article about all the possibilities of Commodore 64 memory configuration. And maybe I should work with him on making a video about that if he wants to. So, good read. I've spent a long time just on this section, but how in-depth it's going, describing just one bit. You know, there's more than a full page worth. While in the C64 Programmer's Reference Guide, it says glossed over. There might just be a sentence or two about it. I just found this amusing. There's an unused byte here. I was talking about how it's at different levels. Here's page 0. Here, a location range from 0 to 8F is actually all the basic working storage. That's actually not totally correct. Really, they should have left the range 0 to 1 is its own section, because it says the portion of 0 page is used by basic only. Well, no. Locations 0 and 1, of course, are used by the processor, and basic and kernel and the programmer all, and just even if you've turned off basic, you definitely need location 0 and 1 to control the memory configuration. And because location 2 is unused, really the basic section starts at 3. But the overall observation is helpful, that this location range is what BASIC uses. If you disable the BASIC ROM, then those memory locations should be free for the programmer to use. And here we go. There's a nice write-up on each one. Just in that last episode, I was talking about the user vector. This vector points to the address of the basic routine, which converts a floating point number to an integer. So this may actually be useful in that user command. I gave that quick example of last episode. This is part of doing a more robust user command. So flags for files, input, the line number, that's the integer line number value, the target line number for GoSub. Here it's talking about the pointer to the start of basic program text, normally 0801. There's a description here that you could, for example, do a very simple PET emulation, really just a memory mapping on the Commodore 64. So there's your PET emulator as a basic program with some pokes. Again, not really an emulator, but where basic variables are stored. Multiple pages about that. So if you want to understand the inner workings of BASIC, this is part of the puzzle here. Should note that this book is not a programming tutorial. This is part of how I've always learned. I would rather have a reference book than a tutorial. There's that floating point accumulator that I showed in that last episode about the user instruction. And a detailed disassembly of the character get routine. This is interesting that Commodore, most of 0 page is used with these vectors and flags and so on, essentially data storage, but they actually put some real code in 0 page. It gets copied down there from the ROMs when you power up the computer. And they give you a disassembly of it here, including their own comments. And this little routine was put in here. It's actually a machine language subroutine. When you start up BASIC, it's copied there, and they put in 0 page to make it run faster. And this was they've used quite a few bytes here to, what is that, 24 bytes to speed up BASIC operation. Random function. So it's funny how so many of the things I did in that last episode are touched upon here. Okay, so we've reached the end of the basic flags. And here, this is the kernel area, which is essentially from all the rest of 0 page. It's not completely true. The last few values are actually free again, but that's a generalization. Almost all 0 page is used up between basic and the kernel. But if you switch those out, they're available to the programmer. So lots of fun stuff here. File use, tapes. The Jiffy clock is stored here. That's the TI string. RS-232, the current device number, which is normally 8 after a disk operation, keyboard buffer, keyboard reading screen, the screen line link table. This is what allows Commodore 64 lines to either have either 40 column or to be 80 columns long as a wrap around. That's pretty clever how they did that. And here's those 4 free bytes of 0 page. So even if you are using C64 BASIC and the kernel, there are 4 bytes available here. Okay, finally through page 0, page 1. This is pretty simple. This is where the processor stack area is. The 6510 stack is 256 bytes long and is fixed in this memory location. But BASIC actually does use some of that space sometimes. For example, and this describes how 4 next loops and GOSIBs and definitions, function definitions, leave entries on the stack as well. You know, I'd actually forgotten that. So if you define a whole bunch of functions like I showed in last episode, then I guess you would get a stack overflow. And I think one of my kids was drawing in here some years ago. Okay, chapter 3, pages 2 and 3, BASIC and the kernel. Now, just that 0 page space is not enough to keep track of all the things BASIC and kernel do, but those ones are all chosen because they're faster in 0 page. So the rest of it goes into page 2 and 3. Basic line buffer, that one of those old episodes I did about, I think probably about abbreviations. I got into this. Keyword abbreviations, that's the line buffer. Keeping track of the open file numbers. Keyboard buffer. All this reminds you that the C64 really does have an operating system. Certainly isn't the most complicated around, but it works. The pseudo 6551 registers. The 6551 is an input-output chip, but Commodore didn't spend the money on putting a real 6551, so they actually kind of emulated it in software and tried to keep it mapped roughly the same with the same settings here. The mock 6551 command register. So a lot of space for RS-232. Basic indirect vector table. There are quite a few places you can hook in to Commodore BASIC here. Again, I think that was that shortcut video where I actually hooked into a couple of these to interrupt the process and show what was going on behind the scenes. Here's where the A, X, and Y registers are stored. When you call the sys command, you can actually transfer directly the A, X, and Y. You can set them and read them again after. I gotta remember that when I do an episode about sys. User routine, last episode. This is where you hook into the interrupt vectors. I did that, I think, with my snowflake routine. Kernel vectors, you can override some of the functions. Most fast loaders hook in here. Kernel load routine. Cassette input-output buffer, which sometimes gets used as an area for sprite graphics. All right, and then this big block from 1K to 40K. Here's the video memory from 400 to 800. And to be clear, this is the default location. That can be moved to anywhere in Commodore 64 memory. There's the 1000 bytes of video memory. And then the sprite data pointers. Again, that all moves depending on how the VIC chip is configured. And then basic program text. There's a huge area of memory. And of course, thankfully, they didn't go through pedantically each of these bytes. It's just a large range where your basic programs are stored. Also describes how the character ROMs are included here in memory, but the CPU does not see those. it just sees RAM at this area, but the VIC chip, if it's pointed here, sees the character ROM, and you cannot define the graphics in this area. And that describes how the auto start ROM cartridge works. These magic bytes, I believe I've talked about that before. When you turn the C64 on, it checks these memory locations. If it sees this magic sequence, it automatically executes. It jumps through the vector here at 8000. That's how some reset protection works, where even if there's not a cartridge inserted, even just poking these bytes into RAM will have the same effect, and the game may set the C64 to automatically crash if you try to reset it, to attempt to avoid being reset and then copied. Okay, Chapter 5, 8K of basic ROM and 4K of RAM. So here's a section where he's talking about how VIC-II that the C64 has is a mixed blessing, because in its day, PET BASIC was quite good. Now it's actually, and this is even from the perspective of 1984, it was not advanced. But on the other hand, a lot of PET software works. And of course, it forced lots of us to learn assembly language. So then he goes through the entire basic ROM, and you can see descriptions of every single statement and where the routine for them is. This is the vector table, the statement dispatch vector table. And it's a table for every command, there's a routine. And it all jumps through here. All the functions, all the mathematical operators, the list of keywords, ASCII text for the basic error messages, and then going through all the routines, such as out of memory, checking for space, displaying the different errors, printing ready, performing list, RAM, ROM. Again, I'm not going to spend forever. About garbage collection. And then finally, the free area of RAM from C1000 to CFFF, all the free RAM that is commonly used for user machine language programs. Okay, here's finally getting to my favorite part. This is all the input-output. So this whole block of memory space is where all the input-output, well, apart from the 6510 input-output port, the VIC chip, the SID chip, the CIA chips, color RAM are all located here in this area. Then there's an overview of the VIC chip. And then going through Sprite 0 horizontal, Sprite 0 vertical position, and so on. And I've noted in pencil, this is years ago, what the default decimal value is. That's kind of a shortcoming in this book. It would be nice if they had shown the default value for every register. Just handy when you're trying to reset your machine. You play around with some values, and then you want your program to put it back, and you're not sure what to put it back to. That's why I wrote some of these out. D011 here, this is one of the VIC registers that's very dense. 6 different functions packed into 8 bits here. The fine scroll of the X position, 24 or 25 row text display. Actually, that's kind of weird that they said vertical scroll by X scan lines instead of Y scan lines. Well, just some value. Enabling bitmap mode, extended color text mode, and so on. And again, it goes into a detailed breakdown of each one. If you're wanting to read more about these registers, this goes into a lot more detail than the Programmer's Reference Guide does. See, this is all just dedicated to that one register. Wow. Okay. DO12, the raster compare register. It's interesting here that says there are 262 horizontal lines which make up the North American, NTSC standard display screen. That's actually incorrect. The original VIC chip in the early NTSC Commodore 64s had 262 scan lines. All the later ones, which especially by 1987 would have been much more common, had 263 horizontal lines. So it's interesting that they were unaware of that and didn't update that in this new edition. So a good write-up on that. Light pen registers, Sprite controls, another dense register, this DO16. It's very similar to DO11, but it's for the horizontal scroll and not quite as dense here. There's a couple unused bits. Again, great write-up. I don't know what happened here. Stains. This is my probably 24-year-old book. Another important register, DO18, where you can redefine both the character graphics, so if you want to do custom characters, and where screen memory is inside the VIC's 16K address space. The VIC interrupt registers. These two combined. This one is where you enable or disable various VIC interrupts, and this is where you check to see if it actually happened or not. Good write-up. Again, with the example programs. More Sprite registers. Sprite collisions, which are not particularly useful because a lot of the things you want to do in a game need more information than these registers provide, but they can be useful. The famous border and background colors, Sprite color registers, and that's it. So that VIC section was huge for me. Now on to the SID. Going through it in great detail. For each of the voices, the various controls, and a description of the filter control. I hope to have an episode about the SID filters soon, once I get this adapter that allows the audio in on the SID chip. And the game paddles also go through the SID because it has the analog to digital converter, and that's also where you read a mouse. And they don't talk about the mouse here because, again, they didn't really update this book in 1987. They should have, but they didn't. Oh, and here's that random number generator that the SID has. In quotes, it's actually the output from the noise waveform, which is like static. And then about color RAM, describing how color RAM works. Okay. Now, this might be my very favorite page in this whole book. And of course, that's where one of my kids, when they were little, this may have been 20 years ago, scribbled all over my favorite page. That's okay. I forgive them. So this chart is something that was missing from the C64 Programmer's Reference Guide, but this shows you how to read the C64 keyboard. Essentially, you write 1 byte to choose which row you're going to read, and then you read it through the other port. You might know that these are the same locations that the joysticks are hooked up to, and this is the source of all the problems with joysticks. I got to do an episode about that, reading the keyboard and the joysticks, and actually maybe just a more fun episode about why the joystick and keyboard conflict. I won't get into that now, but this was huge for my understanding of how to read the keyboard directly through the hardware. It's actually very simple once you understand it, but this was knowledge that eluded me throughout the 80s and half the 90s, and then once I got this was amazing. Highly recommended, page 173. And then they get into great detail about all the different ways that this input-output chip can be used. That the same data ports. Okay, even though this is a reference book, at times the author really does go into quite a bit of prose description. And so it's all about reading the keyboard. Okay, I love this part. Nice little dig here. These same data ports are also used to read the joystick controllers, although common sense might lead you to believe that you could read the joystick that is plugged into the port marked controller 1 from data port A and the second joystick from data port B. There is nothing common about the Commodore 64. Controller port 1 is read from data port B, and controller port 2 is read from CIA data port A. So nice little dig there about the strangeness of how those controller ports are swapped. And because of that choice, that's why games ended up using port 2 most of the time, because there was less interference with the keyboard there. Anyway, like I said, I got to do an episode about that sometime. The problem of mistaking the keyboard for the joystick can be solved by turning off the key scan, but the problem of mistaking the joystick for a key press, the opposite problem, is much more difficult. There is no real way to turn off the joystick. Many commercially available games just use controller port 2 to avoid the conflict. So if you can't beat them, sit back and press your joystick to the left in order to slow down a program listing. The key scan routine thinks that is the control key. And if that were not enough, port A is also used to control which set of paddles is read by the SIT chip and to read the paddle fire buttons. So this is an excellent overview of these registers and something that I had not seen in anything before that. And it gets into a lot of the other, the data direction registers on the CIA chips, time of day clock, that doesn't really get used, except for apparently the basic random statement. Serial data port. I seem to have corrected this. I don't know if that's wrong. I should look that up. And then the second CIA, which is used to point the VIC-II, which can only see 16K. You can point it at any of the 4 groups of 16K, the 4 banks. And this is a good description of that. And also how you have to also tell the operating system where screen memory is if you expect it to continue to work properly. This is also where the RS-232 port is. Talks about the character ROM. And finally, the last or second last chapter is the kernel ROM. A nice write-up about it. And like I was saying, that actually talks a little bit about the different versions. There are multiple versions of the kernel. I want to do a video about that sometime. There were 3 major versions of the C64 operating system. They're fairly minor in difference, but some of the behaviors are pretty major. And my first Commodore 64 actually had version 2 of the kernel, which was kind of buggy. So I want to do a video about that sometime. You can see here that actually BASIC has overflowed, like I mentioned. It's not, we talk about 8K of BASIC and 8K of kernel, but no, BASIC is actually about 9K. So the first section here of the kernel ROM is still continuing on with BASIC commands. Up to about here, E460. And here's this little section of patches added to later kernel revisions. They try not to move anything in memory for compatibility. So apparently there's a bit of extra code in here. I haven't really studied that before, but that would be interesting to learn more about. Here's a description here of the color RAM. That's one of the major differences, how the color RAM is initialized in different versions of the kernel. Okay, about cursor mode, outputting characters, the print routine, which isn't in BASIC, it's actually a kernel function, an operating system function. Keyboard decoding, serial bus. Remember that the disk operating system isn't stored in the C64 kernel. There is code to communicate with the disk drive, and that's up to the disk drive to actually implement the functions. Opening files to devices on the serial bus. RS-232 input-output. Loading RAM from a file. Some of the reset routines, including the famous 64738. 64738. Power on reset routine. Quick walkthrough of what it does. This initialize screen editor. This is a way if you've written a game or a demo, you can actually call this routine and it will clean up pretty nicely after itself. Turbo Macro Pro, I believe, uses this routine as part of its reset feature. So when you hit restore or do that jump back, it cleans up after itself quite nicely. And I think that's part of what it uses. The kernel jump table. If you haven't heard of this, this goes back to the PET days where the PET, the VIC-20, the Commodore 64, the Commodore 128, the Plus 4, all share a jump table in common that handles the basics like loading, reading the keyboard, talking a disk drive, and so on. Oh, talks about a difference in the SX64 here. And the PET64, it even gets a reference here. So that's the kernel version identifier byte. I'm going to have to look into that more. And the last 6 locations of memory are the interrupt vectors. Now note by default, the kernel overrides these and points into those much earlier ones back at 0318. Right here, NMI. So these are like the soft versions of these vectors. These are the actual processor ones. So if you switch off the kernel ROM, then you have direct access to these RAM locations and you can point the interrupts to whatever you want. This is a little faster than that indirect jump to the kernel one. And then finally a GEOS section, which really I haven't spent much time with, but has a nice overview of GEOS. Actually, I was just asked if I would make an episode about GEOS programming. I did a little bit of it way back when. I hardly remember any of it. I'm interested in that. That might be a lot of work. I'll see if I eventually get to that. But yeah, GEOS has these pseudo registers. So it's slower, but it gives you 16-bit registers. And the operating system uses some of them, and some of them are available to user programs. But it's just like a whole nother, well, it is a whole other operating system. And it talks about where your video memory, the bitmap mode that it uses, printer drivers, other routines involved in printing, using the disk drive, jump vector to the short program used to reboot GEOS, and so on. Anyway, it's an excellent overview. This is not enough to program GEOS on its own. Well, actually, nothing in this book is enough. It's not a complete programming course, but it's an excellent reference to the map of the Commodore 64 in both regular Commodore BASIC and in GEOS. Okay, we're not going to go through all that. And then finally, it has some appendices about how to type in the programs, screen location, screen color codes, color RAM, ASCII codes. Disappointed that it doesn't include a hex value. They have quite a bit of room here. I think they could have squeezed in a hex row. That would have been very useful. In some cases, I've gone through and written in the hex equivalent. Screen codes again without the hex. Key codes for scanning, peeking location 197. Those are the codes that come back. That's handy. I don't think that's in the programmer's reference guide, and it should have been. Okay. And finally, an index. It's kind of funny to see an index by memory location, so there's huge numbers where you might expect page numbers normally. I just find that amusing, but of course it's very helpful. And then there's a second index added to this later edition that has all the GEOS addresses. I wish they actually included the normal C64 memory map last. But anyways, otherwise you got to flip past the GEOS one, which probably less people were interested in. Okay, and that's it for the book. I love this quote. I just wore out my first copy after several months of extensive handling, and am rushing to get another one before my programming comes to a standstill. From TPUG magazine. Okay. All right, so that's it for mapping the Commodore 64. Thanks as always for your support. Thank you each one of you that have been with me, some from the beginning and others who are just joining on now. I appreciate all of you. Thanks for watching, and we'll talk to you next time.